Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, in a previous class of fourth chapter, we discussed what actually center of gravity and on which factor does it depend, and we discussed even how to find out the center of gravity of a different objects. Especially there we discussed according to our syllabus regular bodies. So how can we calculate the center of gravity of regular bodies? In this session, we are going to discuss about the main difference between uniform linear motion and a uniform circular motion, and after that we will discuss even the differences between centripetal force and a centrifugal force. So before getting to the topic actually, dear children, let us recall the few basic terms which we had learned already. So here, look at here, rest, dear children. So what is a rest? So rest means what we will take whenever we tired. It is not that actually. So when you can say that a body is in rest or body is at rest, dear children. So very important thing is that if any object is not changing its position with respect to the surroundings, it's very important. With respect to the surroundings, then a body is said to be at rest. The best example, your building or else any building you can take with respect to the earth surface, said to be at rest. Said to be at rest. Then what is motion, dear children? So here, if any object is changing its position with respect to the surroundings, then that particular body is said to be in motion. The best example, same building you can take, but by this time with respect to the space. How with respect to space our building will be in motion, dear children? Because earth is in motion. First of all, earth is not at rest. With respect to the space, so earth is rotating, earth is revolving. So what are the objects or things which are attached to the earth also what are in motion along with the earth? So that's what we can say that your building with respect to the space is in motion, which means what? Same body can be at rest, can be in motion. Okay, that is fine. So motion means actually, dear children, we have a different types of motions actually which we learned in the previous sessions actually. Now here we are very much interested about linear motion. So what is a linear motion? When you can say that a body is in linear motion. Children, it is also called as rectilinear motion. Even it is also called as one-dimensional motion, which you have learned in the previous classes. Dear children, here let us take, here is some horizontal surface. Okay, let me take, here is horizontal surface, means it is like a straight line path, I can say that. So here, if this object is going along a straight line path, such a motion is called actually linear motion. So here, what is the matter here? The path along which it is going is very important, means it is straight line path. If any object is going along a straight line path, then such a motion is called actually linear motion. But dear children, whenever any object is going like straight line path, do you think that it covers equal distances in equal interval of time? Is it possible? In general, it is not possible. Means practically it is not possible generally. So in some specific conditions, under some specific conditions it may be possible, but generally practically, just you think a situation, you are going in a car like 1 meter in 1 second, 1 more meter in 1 second. Do you think that we will be checking like that and we will be driving? It's not that. Their accelerator will be there. So just we will be increasing the speed continuously. And whenever there is a head brake or any things will come across our vehicle, again just will apply the brakes, means it is decelerated. So it means what? Either vehicles will go with acceleration or deceleration, but not with the uniform motion, which means what? Covering equal distances in equal interval of time. Suppose, let us take a situation where an object is going along a straight line path. At the same time, it is covering equal distances in an equal interval of time. Then what can we say? We can say that that particular body is moving with uniform linear motion. Now look at here, what actually uniform linear motion, very important. So when we can say that a body is in uniform linear motion, dear children. So the best example is that body should go along a straight line path. Why? Because it is a linear motion. It is a linear motion, so it has to go along a straight line path. And here, for example, dear children, let us say it is A, it is B, some point C, it is D, some, let us say it is a point E. Okay, now so that it is, let us say it's a 5 meters, and this is also it is 5 meters, and it is also 5 meters. Means they are equally separated, let us say, some points equally. Let us some stops A to B, B to C, something like that. And here an object, this is object, let us say. So it is going. Children, first of all, the thing which you have to observe, what is a path? What is a path? Along which path it is going? Yes, it is going along a straight line path. So it is a linear motion only. It is a linear motion only. So to cover from A to B, that is 5 meters, let us take, it is taking a 1 second of time. Even B to C, 1 second of time. C to D, 1 second of time. D to E also it is taking 1 second of time only. Which means what, children? It is covering equal distances in a equal interval of timings. Then this body is said to be in uniform linear motions. Very, very, very important. Very, very important. Now, dear children, let us recall about what a concept of speed. What is speed, dear children? Rate of change of distance is called actually speed. But in this case, dear children, equal distances are covered in equal interval of timings. Then what can you say about the speed of this particular body? Yes, speed of the body is uniform. It's very, very important. So in this, let us write speed is uniform. But dear children, in one-dimensional motion along a straight line path, whenever body has a linear motion, dear children, as it is going along a straight line path, displacement is equal to distance and the velocity is equal to speed. It's very, very important. Means in a one-dimensional motion, dear children, in one-dimensional motion, so the body is covering equal distances in equal interval of timings, which means what? It is covering equal displacements in equal interval of timings, because in one-dimensional motion, distance is equal to displacement, because there will be particular direction. There will be particular direction. So what can we say? In uniform linear motion, in a uniform linear motion, not only like a body is moving with a uniform speed, but also it has uniform velocity. So the very important thing is that in this uniform linear motion, dear children, speed and velocity are uniform. It's very, very important. Now with this, we can redefine what actually uniform linear motion, dear children. It's very, very important. Means if any body, if any object is moving with uniform speed along a straight line path, such a motion is called uniform linear motion. I repeat once again, if any object is moving with a uniform speed along a straight line path, means in order to have a uniform linear motion, two conditions are there. What is that? Body must go along a straight line path. At the same time, it must have uniform speed. Is very, very important. Two things. I repeat once again. Body must go along a straight line path. At the same time, body must have uniform speed. Then only we can say that body has uniform linear motion. Fine. And as I told you that in what we can say linear motion, speed and velocity both are same. So body has same velocity. That is a uniform velocity. That is velocity of an object in a linear motion is a constant. Of course, if it is going with a uniform way, means it's covering equal distances or equal displacements in a equal interval of time. But let us recall once again what actual acceleration is. So we know that acceleration is equal to change in velocity. But dear children, look at this. In this case, so as it is covering equal displacements in equal interval of timings, then at any point, dear children, if you can take, its velocity is 5 meter per second only. Its velocity is 5 meter per second only. Just let us suppose, because dear children, whenever a body is going with a uniform motion, it's what we can say at any point, that is called instantaneous velocity. So we can take it as a velocity will be same, equal to the average velocity, because same displacements are covered in a same interval of timings. So here the very, very important thing is that here, so velocity of an object in this case I am talking 5 meter per second at any point. Here, which means what? Body is going with the what we can say same velocity. Then what will be the change in velocity? Here 5 meter per second, here 5 meter per second. Then what is change in velocity? There is no change in velocity at all. So here change in velocity is 0. So 0 by time. So 0 by something is 0 only. So acceleration is 0. So dear children, so the body which is in uniform linear motion, what about its acceleration? Do you think that the body has acceleration? No, body does not have acceleration. So it's a very, very important point to understand, dear children. So any object, if it is going with a uniform linear motion, what is its acceleration? Its acceleration is 0. It's a very important point. Just let us note down it. So, acceleration of an object is 0. So, there is no acceleration. There is no acceleration. As there is no acceleration, that's what, as there is no acceleration for any object which is going with a uniform linear motion, that's what this uniform linear motion is also called as unaccelerated motion. Unaccelerated motion. In exam they may ask you the question, why uniform linear motion is said to be called unaccelerated motion? The reason is that in a uniform linear motion, the velocity of an object is a uniform. So, as there is no change in velocity, there is no acceleration. There is no acceleration means what actually? Acceleration is 0. As acceleration is 0, that's what we can call it as a unaccelerated motion. Dear children, this is all about uniform linear motion. Here I repeat once again, dear children. So, in order to be in a uniform linear motion, there are two conditions are there. So, the object must go along a straight line path, first point. And the second point is that the speed of the object should be same. And here one more very important thing is, dear children, in a uniform linear motion, dear children, speed and velocity both remain same, both remains constant. So that the acceleration of an object is 0. That's what this uniform linear motion is also called as unaccelerated motion. So this is all about actually uniform linear motion. Now, dear children, we will see what is actually circular motion and how does it differ from linear motion. So, in a linear motion, in special case which we study is that uniform linear motion. So, here also we can study about uniform circular motion. Now, we will discuss what actually circular motion. Dear children, once again let us recall what is actually linear motion. If any object is going along a straight line path, its motion is said to be called linear motion. Means there, what is the path actually? It is going along a straight line path. But here circular motion means what actually? Body should go along a circular motion, circular path. So if any object is going along a circular path, then its motion is said to be circular. The best example, electron revolving around the nucleus. Electron revolving around the nucleus is said to be in a circular motion. Even you can take a planet, almost planets are going in a circular path around a sun actually. But here one very important thing is that, dear children, it is not compulsory that the body which is going along a circular path should cover equal distances in equal interval of time. It is not compulsory always. But we will take a case where object covers equal distances in an equal interval of time along a circular path. Then what can we say? We can say that that body is in uniform circular motion. Uniform circular motion. So again I repeat, which means what? In a uniform circular motion, body has uniform speed. In exam they may ask you to define what actually uniform circular motion. So how we should define? The body which is moving along a circular path and which has uniform speed is said to be moving in a, or is said to be has uniform circular motion. Is said to be moving in a uniform circular motion. So very important. I mean, two things we have to remember regarding uniform circular motion, dear children. The very important thing is that we'll decide whether body is moving with the body is in uniform circular motion or not. So uniform speed. So speed must be constant. That is fine. But what about velocity? Because in a uniform linear motion, speed and velocity both remains constant. Then what about the speed of an object which is in uniform circular motion? Let us see now. For that, dear children, so to make it more better, here let us make a diagram little bit big. Let us make. So let us take uniform circular motion. Let us say such that here is its center. Dear children, here what I mean to say that here let us take, for example, here one point let us take A, okay na? And here let us take a point B, let us take here point C, here point C, any point you can take. It is not that we should take only 4 points. Any point means at any point and what is circumference you can take, at any point you can take any point, but these are the bit convenient points to us to understand the concept. Now what I mean to say that, for example, dear children, from A to B is like a 10 meters, B to C is a 10 meters, like a C to D is a 10 meters, D to A is a 10 meters. Now just assume a case, children, it is a completely assumption. To move from point A to point B, it is taken a time of 1 second. From B to C also 1 second, C to D also 1 second, D to A also 1 second. Means 10-meter distance in a 1 second. Means it is covering equal distances in equal interval of time, let us think, but in a circular path. That's what I am using a distance word here, circular path here. So then what is its speed, dear children? At any point if you can take, its speed is 10 meters per second. 10 meters per second. At any point you can take, the speed is 10 meters per second. That's what speed is, a uniform. What about velocity? If you can think about the magnitude of the velocity, children, the velocity I am talking here, velocity magnitude, try to understand here. So velocity magnitude also same only, 10 meters per second only. The children, try to understand here, the magnitude of the velocity always equal to the magnitude of the speed. But dear children, still can we say that the body which is in a circular motion has uniform velocity? No, we cannot say like that. Why? Because here velocity is a vector quantity. We have to consider its direction also. Now what will be the direction of velocity of an object which is in uniform circular motion? So it's a very important, remember that. So the direction of velocity of an object at any point is always along the tangent. Means it will be like this. For example, here at this point, the velocity direction will be like this. So this is velocity direction. It is represented here velocity. Actually, direction of velocity. Means what, dear children? At every point, the direction of velocity keeps on changing. Means its magnitude is a constant only, but not direction. So velocity is not a uniform. Velocity is a variable. So very important. So dear children, here the point what we can learn here, in a uniform circular motion, speed is a uniform, but velocity is variable. So very important. Velocity is variable. So its direction. Children, see, as velocity is a vector quantity, we need to think about the magnitude and as well as direction. Its magnitude might be same at every point, but not direction. So definitely there will be a change in the velocity. Means here change in the velocity, which means what? We are talking about its a direction. Then what can you say about the acceleration? Does a body have acceleration or not? Just once again recall the concept of uniform linear motion. In a uniform linear motion, as velocity is a uniform, so there is no change in velocity, there is no acceleration. But whereas when you think about a uniform circular motion, dear children, so here body which is in uniform circular motion, its velocity is not uniform, its velocity is a variable. So definitely body should have some acceleration. Children, let us recall what is acceleration? Rate of change of velocity. The change might be in magnitude, the change might be in direction, sometimes change might be in both. It is not that only the magnitude changes so that there will be acceleration. It is not that. Even if direction of velocity changes also, acceleration will change. So that's what body has some acceleration in this. So here, let us write here acceleration, dear children. That is, acceleration of the body which is in a uniform circular motion is not zero. That's what uniform circular motion is also called as accelerated motion. So very important. Uniform circular motion is also called as accelerated motion. Children, it is a very important question. Why uniform circular motion is called as accelerated motion? So what we should write? We should say that the body which is in a uniform circular motion, its direction, its velocity direction keeps on changing. As the velocity is a variable, definitely there will be some acceleration. That's what uniform circular motion is also called as accelerated motion. So children, this is what actually about a uniform linear motion and a uniform circular motion. Just let us recall once again. What actually uniform linear motion? The body with a uniform speed should go along a straight line path. Uniform circular motion what? The body with a uniform speed should go along a circular path. circular path. And a uniform linear motion, in that body acceleration is 0, whereas in a uniform circular motion body acceleration is not 0. So uniform linear motion is also called as unaccelerated motion, whereas uniform circular motion is also called as accelerated motion. So dear children, this is what actually uniform linear motion, uniform circular motion. Now children, let us consider either one particular object which is going along a straight line path. But what happens if a constant force will act on that particle or object which is going along a straight line path continuously and moreover perpendicular to its direction? I repeat once. Dear children, just imagine one object is going in a straight line path. What happens? A force acts perpendicular to its direction continuously, that too with a constant magnitude. What will happen? Let us see once again. Children, let us take, here is an object. Let us say this is an object. Okay, na? So initially let us say it is going like this, in a straight line path it is going. Just you think that straight line path it is going. What happens if a constant force like this, capital F force, is acting perpendicular to this direction? Then what will happen? Do you think that it will go along a straight line path? No, it's not that. What happens? Its path is changed. Means here what happens? This body which has reached here, let us think just, so it may go like this. Okay, na? Again, as I said that continuously it is acting. So now just imagine the force here. So what happens? Here again the body whatever has reached here, so it may go like this. It may go like this. If again a force, just imagine like this. Just imagine it, at every point, at every moment, a constant force acting continuously, moreover perpendicular to its direction. So what happens? So its direction keeps on changing. So here also, let us say this is what actually capital F force acting. Same force, I mean to say constant force, that the magnitude is same only. So the particle has reached here, again here force acting perpendicular, then definitely what will happen? Here it will try to move in this direction. Okay, again here some force is acting, again what will happen? It will try to change its path here. Again if its force is acting like this here, force acting like this, what will happen? Again it will change like this in this direction. Means again if here force is acting perpendicular to its direction, what will happen? Again its path is changed. Means dear children, so here means at every point we have not taken here. Means now just you think about the situation where if the force is acting continuously perpendicular to its direction, that to constant magnitude, that is a same magnitude force, then what will happen? You know, no more straight line. Means the body cannot go along a straight line path. Rather what happens? Just you think, so it is going in a circular path. So try to understand. So very important. Very means very much important. Means if here it's not like a, here what we have taken, here I have taken a force, here I have taken, it's not that. If force acting at every point, what happens? You know, body is made to go in a circular path. Dear children, the force which is responsible for this only we can call it as a centripetal force. It's a very important. Centripetal force. So children, what is centripetal force? What is centripetal? Dear children, here very important question. What is that force which is required to keep a body in a circular motion? So very important examination point of view. So what you should write? You should write it is a centripetal force only. In exam if they'll ask you to definition, then what is the direction of centripetal force, dear children? The direction of centripetal force is always towards the center of circular path. Always, you can look at here, any force, the force you can take at any point, at any point, you know, the centripetal force direction is always towards the center of circular path. Then how to define? In exam they may ask you to define the centripetal force. How to define? The force which is acting towards the center of the circular path is called centripetal force. Then how can we calculate its magnitude? It's very important. For suppose, whatever the particular object which is going in a circular path, let us say its mass is m. M is the mass of an object which is going in a circular path, and its velocity, its speed is, let us say, v. Its speed is v, and such a way that r is the radius of the circular path along which it is going. Then the magnitude of the centripetal force can be calculated by using this formula. F is equal to mv square by r. So, it's very important. So, this is a formula which we use to calculate the magnitude of the centripetal force. This is fine. Now, let us try to see a few examples where centripetal force will come into the play actually. For example, dear children, let us take the first one. Let us take, solar system. Let us take here is solar system. Dear children, so as we know that almost all planets are moving in a circular path around the sun. Almost I am saying, it's not exactly circular path, almost we can take. So now let us take the case of Earth and Sun. Earth and it is going around in a circular path around the Earth only. So let us take that case. So children, so here is circular path. So here is a circular path where let us say here is Earth is there. Where is Earth? And let us say here Moon is there. Here is Moon. Here is Moon. Let us say here is, let us write Moon, here it is. So obviously, children, any object or any particle, it is going in a circular path, which means what? There must be some centripetal force. Then only what happens? Body is made to go along a circular path. If not, it will go in a straightened path only. So here what will happen here? So this is what actually. Centripetal force direction will be like this. But dear children, here, what is that source providing centripetal force in this case? Very important. In exam also, they will ask this question. So what is that external source which is providing centripetal force for this Moon, so that Moon is going in a circular path? So what is that force, dear children? It's a very important. Gravitational force, dear children. So in this case, gravitational force provides required centripetal force. Children, you can take any two objects in the solar system which are going in a, if they are going in a circular path. So definitely there must be some centripetal force. So what is the source for that centripetal force? Gravitational force. Now let us take one more example. So now let us take nucleus electron system. Nucleus and electron system. Let us take nucleus and electron. So we know that electrons are revolving around the nucleus in a circular orbits. So here is, let us say that circular path or a circular orbit, and this will be the nucleus. Let us say here is a nucleus, and here let us say this is electron. This is a electron is revolving around the nucleus. That is fine, and it's common thing that as electron is going along a circular path, definitely there must be centripetal force, and centripetal force direction is always towards the center. But here, what is that external source? So what is that external source providing centripetal force for that electron, so that electron is going in a circular path, circular orbits around the nucleus? So here, dear children, what is that? Electrostatic force, very important here. Electrostatic force. So here electrostatic force is providing the required centripetal force. Now let us take one more example. So here let us take a string and stone case. String and stone system. So children, just imagine a situation where string, for that string a stone is attached and it is wheeled like this in a horizontal plane, circular path. So that what will happen? That stone is going in a circular path, in a horizontal plane, So as the stone is going in a circular path, so obviously there must be some centripetal force. So look at that case. So here is, so it's not like this. For example, here is circular path. Let us try to draw. Here is, so here is that stone. Children, here is a stone, so which is going in a circular path actually. So there must be some centripetal force, so that what happens, that stone will go in a circular path only. But here what is that external source which is providing centripetal force, children? So in this case, force of tension. It's very important. Force of tension provides required centripetal force. Required centripetal force. Children, it's a very important thing is that what is that external source which is providing centripetal force in this case is very important. So in this case, dear children, gravitational force is providing centripetal force, whereas in a nucleus electron system here, electrostatic force is providing, whereas in a string stone system, dear children. So what is that external source? Here is force of tension. So that force of tension, it will be acting on our finger as we are will, and it is will like this, that centripetal force will be acting on our finger, means towards the center of that circular path. Okay, dear children, just you copy it. But here, dear children, we must get one doubt actually. What is that doubt? If only centripetal force is acting on a body continuously, then what should happen actually? What should happen? Look at here. Let me just, here let us take it as circular path. Here is circular path. Here one object is going in a circular path only. Let us say it is the center. So as we know that centripetal force will act towards the center. Means what? What is actually the duty of centripetal force, dear children? So it has to pull. So at every point on this, what we can say this path, at every point, it has to pull the object towards center only. Here is object, it has to pull towards the center. Here the object, it has to pull the center. So everywhere, it has to pull towards the center only. Means here the point is that if only centripetal force acting on the body continuously and it is trying to pull the body towards the center, then don't you think that after some time or some years, the body has to go towards the center? Let us think about the sun and earth case only. As centripetal force is acting on earth and it is trying to pull the earth towards the center, then after some years, our earth should go near the sun, right? Continuously, slowly it has to go. But is it happening like that? No, it is not happening like that. Why? What is the reason? Dear children, whenever a body is in a circular motion, one more, a pseudo force will come into play. What is that? Pseudo force. Fictitious force will come into play, which will act away from the center and whose magnitude is equal to the centripetal force. That force only we can call it the centrifugal force. What is that, dear children? Centrifugal force. Very. So what is the centrifugal force, dear children? It's very important. The force which is acting away from the center of the circular path. Then what about centripetal force? The force which is acting towards the center of the circular path. So means both are quite opposite, which means what here? If centripetal force, let us say it is F1, let us take centripetal force as F2. Just its assumption only. So then F1 will be acting towards the center, whereas centrifugal force will act away from the center, But the point is, a very important point is that, dear children, the magnitude of centripetal force and the centrifugal force are equal but opposite in direction. For suppose example, if F1 is 1000 newtons, F2 also 1000 newtons. So these two forces are equal in a magnitude but in an opposite direction. So we can write like this: F1 is equal to minus F2. F1 is equal to minus F2. That is what actually centripetal force is equal to, all dot will go. So centripetal force is equal to minus centrifugal force. Children, this minus represents opposite in direction, that's it. Dear children, once again let us recall Newton's third law of motion. What is the Newton's third law of motion? We know that, dear children, every action has equal and opposite reaction. So this is what actually Newton's third law of motion. Just now try to compare, try to think here. Action is equal to minus reaction. Centripetal force is equal to minus centrifugal force. Now let us make one question in our mind. Can the centripetal force and the centrifugal force form action-reaction pair? So try to understand. Can the centripetal force and the centrifugal force, do they form action-reaction pair? What do you think? Just you think here. So action is equal to minus reaction. So here centripetal force is equal to minus centrifugal force. Children, just you think about. So pause the video, just think and comment your answer. What do you think? Do they form action-reaction pair or they do not form action-reaction pair? Just you think and comment your answer. Hope you thought fine, dear children. And here, dear children, generally by seeing this, many of us will come to the conclusion that yes, they do form action-reaction pair. Why? Because here action is equal to minus reaction, Here centripetal force is equal to minus centrifugal force. But dear children, the surprising thing is that centripetal force and centrifugal force, they do not form action-reaction pair. What is the reason? So let us recall about the concept of centripetal force and centrifugal force. Okay, it's not that. Let us recall the concept of action and reaction. Newton's law. For example, dear children, here is a board. Okay, now what I am going to do? Just I am going to touch this board like this. I am hitting this board, hitting this means what? I am applying force on the board. It is action. Try to understand. I am applying the force on the board is action. But dear children, don't you think that there will be impact on my hand? Obviously there will be impact. So who is that reason for that impact? Board. So here, as I am like applying the force on the board, in result what is happening? Board also applying same amount of force on my hand here. So here now just let us think in detail here, in depth let us think here. So the force which I am applying on the board is action, In result what is happening? Board is applying some force, means equal force on my hand. It is a reaction. So children, action is acting on board, reaction is acting on my hand. Means here, do you think that action and reaction, both forces are acting on the same body? No. Action is acting on one body, reaction is acting on another body. So here, how many bodies are involved? Two bodies are involved. Children, please think 1 second, just try to understand here. So action will act on one body, reaction will act on another body. So they are not acting on the same body. But come to the concept of centripetal and centrifugal here. In this case, let us say here is sun. It is a sun, let us say. And here is the earth. Earth, dear children. Where the centripetal force is acting? On earth only. Where the centrifugal force is acting? On earth only. That is the reason why centripetal force and the centrifugal force, they do not form action-reaction pair. Children, for example, two forces are given, dear children. Do they form action-reaction pair? So we have to check three things. First thing, they should be equal in magnitude. Second thing, they should be opposite in direction. But third thing, they should act on two different bodies but not same body. Here, centripetal force, centrifugal force, both are equal magnitude, happy only. Both are in opposite direction, very good. But are they acting on two different bodies? No. They are acting on the same body. That's what centripetal force and centrifugal force, they do not form action-reaction pair. It's a very in examination, it's a straight question. Do they form action-reaction pair? So you have, what you have to write? You have to write, no, they do not form action-reaction pair. What is the reason? They might be equal in magnitude and opposite direction, but they do not act on two different bodies. Rather, they act on the same body. In order to form action-reaction pair, these two equal and opposite forces should act on two different bodies. That's it. So that is the reason why centripetal force and centrifugal force, they do not form action-reaction pair. Acha, then in examination, they will ask you the question then. What is the ratio of the magnitudes of the centripetal and centrifugal force? Children, it's very important. So here the magnitudes of the centripetal force and the centrifugal force, the ratio is always 1:1. Why? Because both are same in magnitude, right? So both are equal in magnitude. That's what the ratio is, always 1:1 only. As children, so where we can like centrifugal force actually, do we have any application? Dear children, so many of us, we are using washing machines. So if you can notice that what washing machine, dear children, so when the the cloths which are like placed in that, when it is being worked, what will happen, as the drum will be there, washing machine drum, so that will be being rotated. But during that process, what will happen, these clothes are thrown like away towards the drum, So during that process, what will happen? That holes will be there for drum, right? So due to this, what are centrifugal force, as the clothes are thrown towards the drum, so what will happen? They are compressed. So what will happen? The water is removed from that. So that is the best one actually. That's what we can say, that washing machine which we are using, there will be a involvement of centrifugal force. It's a very important. Children, in exam, they will ask you to write the differences between centripetal force and centrifugal force. So what you have to write? Centripetal force, the force which is acting towards the center of a circular path is called centripetal force. Whereas centrifugal force, the force which is acting away from the center of a circular path is called centrifugal force. Whereas centripetal force is a real force, centrifugal force is a pseudo force. It's not a true, it's not real force. It is a fictitious force actually. So this is what actually you have to write. Okay, dear children. So dear children, these are the concepts which we have discussed in a circular motion. Let us recall once again what we have discussed. Dear children, in this circular motion, it's a unit C of a first chapter of force, dear children. First we discussed what is a linear motion, what is a uniform linear motion, what is a circular motion, what is a uniform circular motion, and finally we discuss about what is a centripetal force, what is a centrifugal force. Children, it's very important thing is that do they form action reaction pair or not. It's a very important. So dear children, in next session we will be like we are going to make a video on the numericals, very important children. So far just we are discussing the concepts only. We have not solved the numericals and even we did not discuss the exercise questions. So next in upcoming videos just we are going to solve the numericals. At the same time we are going to discuss each and every exercise questions. Yes, till that time just continue your preparation. Okay children, thank you so much, all the very best.